The ElmorLabs PMD2 lets you measure and log the voltage, current, and power flowing through your CPU, GPU, and motherboard power cables. In this video, we show you what's in the box, how to set up the device, and how to use the PMD2 for your system monitoring needs. In the box, you can find the ElmorLabs PMD2 circuit board, a 2.4-inch OLED display, one ATX 24-pin cable, two EPS 8-pin cables, three PCIe 8-pin cables, an adjustable stand, a 1 meter Type-C to Type-A USB cable, Velcro strap, one 12-volt high-power PCIe 5.0/ATX 3.0 cable, and one acrylic case with mounting hardware. Before we continue, it's important to mention that the supplied cables should only be used to connect the PMD2 to the hardware. They should not be used to connect the power supply to the PMD2. The ElmorLabs PMD2 comes with an improved feature set compared to the original PMD. Let's get the PMD2 ready for prime time. First, we're going to attach the screen to the PMD2. Attach the golden standoffs to the PCB with 4 small screws. Then plug the screen into the PMD2. And finally, fix the position of the screen using 4 additional small screws. The next step is to attach the acrylic case to the PMD2. First, attach the small standoffs to the back acrylic case with 4 screws. Then fix the PMD2 PCB to the acrylic back panel by using the 4 larger standoffs. And lastly, attach the front acrylic panel to the PMD2 by using 4 black screws. You can now also attach the stand to the back of the acrylic case or just leave the device like this. Now we're ready to plug the PMD2 between the power supply and our system components. The first step is to connect the PSU cables to the PMD2. If you hold the PMD2 in front of you, the bottom and right connectors are for connecting the PSU. The connectors are also clearly marked with an "in" suffix. If you hold the PMD2 in front of you, the top and left connectors are for connecting the system. The connectors are not interchangeable, meaning you must, for example, connect PCIe 1 in to the correct PCIe 1 out. If the PMD2 has power, it will make a beeping sound. The ElmorLabs logo will appear, and you'll find the measured values on the display. Next, we'll configure the device itself. You can access the on-device configuration options by long pressing the button on any menu. To configure any option, first long press on the option, then short press to cycle through the options, and once again long press to select the option. Make sure to cycle to the save option, then long press to permanently save your configuration to the device. There are 3 on-device configuration options. Average determines the measurement value update interval. The measurement value is the average of all values collected during the measurement interval. OCP warn sets the overcurrent threshold above which the OCP alarm will sound. PS on enables the PS on signal from the 24-pin ATX power supply cable, enabling the power supply. The ElmorLabs PMD2 comes with its own dedicated software. The software has multiple purposes: monitoring, logging, and device configuration and calibration. To get started, first connect the PMD2 to your system via the USB Type-C cable. Then open the software. If everything is installed correctly, the device will show up as PMD2-0. The 0 at the end means that it's the first connected PMD2 device. If you connect multiple PMD2 devices, they'll show up as PMD2-1, PMD2-2, and so on. Now click Connect to start communicating with the PMD2 device. Let's highlight the main software features. The most obvious feature is telemetry monitoring for the 46 data points, which includes 14 power connectors with voltage, current, and power, as well as 4 aggregate figures: total power, EPS power, PCIe power, and motherboard power. By default, the chart displays the values of the past 20 seconds. However, you can adjust the duration. The min-max values for each monitored value represent the minimum and maximum values of the chart. The next important feature is the logging functionality, which supports 3 outputs: to the hardware info software, write the latest value to a text file, and log all the values to a CSV file. The last feature is device configuration and calibration. This allows you to define the polling interval, basically how often the software fetches the telemetry data from the microcontroller, as well as calibrate the device measurement accuracy. You can find the latest software on the ElmorLabs website. Let's now take a look at an example how to export the telemetry. To start the telemetry export to hardware info, first make sure the checkbox is checked, then click Start Logging. Now you can launch the hardware info software and you'll find all PMD2 telemetry readings updating in real time in hardware info. If you wish to write it to a CSV file, you can follow the same process but simply check the CSV checkbox. To stop logging, simply click Stop Logging. The most advanced feature of the PMD2 is the calibration, which enables you to adjust the gain and offset for each telemetry parameter. This is particularly useful for customers who want to calibrate their specific PMD2 device using more accurate measurement equipment. The PMD2 devices are calibrated from the factory, so for most regular users, this feature is not needed. The linear formula for the calibration is as follows. The PMD2 allows you to read and write the calibration values from and to the microcontroller's volatile memory, or RAM, or load and store them from and to the microcontroller's permanent storage, or flash. For more details on how to calibrate the device, it's best to reach out to us directly via the ticket system on our website or stop by our Discord channel. The PMD2 is pretty straightforward to use, so it shouldn't be too difficult to make full use of it. Perhaps one pointer that's useful for those looking to fine-tune the measurement interval is to match the software polling interval and the device averaging. In short, you want to make sure the software polling interval is not lower than the device averaging interval. Otherwise, you'll read specific values multiple times. For example, if the device averaging is set to 135 milliseconds and the software polling interval is set to 50 milliseconds, then the software will fetch values from the microcontroller more than 2 times faster than the microcontroller stores new readings. As a result, you will read values 2 or 3 times. If you have any questions related to the ElmorLabs PMD2 hardware or software, feel free to stop by our Discord channel.